Now, when we're considering the endocrine system, we need to think about negative feedback, because homeostasis is absolutely vital. We need just the right amounts of the endocrine hormones present in the blood, because they're very physiologically active. So how is this achieved? Well, we can start off at the top here with the hypothalamus. At the base of the brain. Then the next level of control down is the pituitary gland. The pituitary gland. And we're thinking about the anterior lobe today. The anterior lobe of the pituitary gland, which is the glandular part. That's sometimes called the adenohypophysis, because it's glandular. And if we start off with thinking about the example of the thyroid gland. So there we've actually got three anatomical structures. We've got the hypothalamus, which is an anatomical structure. We've got the anterior lobe of the pituitary gland, which is a definite anatomical structure. And we've got the thyroid gland, which is an anatomical structure in the neck, as you know. Now, if we think about thyroid hormone, essential to regulate the amount of metabolism going on in the body, essential during growth and development for normal growth of the body, essential for normal development of the nervous system. But we don't want too much, because we don't want it to overstimulate metabolic processes. So when the levels of thyroid hormone are low, the hypothalamus will start things off, and it will produce a releasing hormone called thyrotrophin. Releasing hormone or releasing factor. Thyrotrophin releasing factor. And this will stimulate the pituitary gland. And when the pituitary gland is so stimulated, the pituitary gland is going to release TSH, thyroid stimulating hormone. And the thyroid stimulating hormone will stimulate the thyroid gland, and as a result the thyroid gland will produce more thyroid hormone. And that comes in the form of T3, triiodothiamine, and T4. The difference is the amount of iodine. That's got 3 atoms of iodine, that's got 4 atoms of iodine. So I think you can see now we've gone from the hypothalamus releasing the thyrotrophin releasing hormone or releasing factor, down to the pituitary gland, which is stimulated to release the thyroid stimulating hormone. That goes in the blood down to the thyroid gland to increase the amount of thyroid hormone. So now we've got what we wanted. We've got more thyroid hormone in the blood. But of course we don't want too much thyroid hormone. We don't want this process to keep going on. So what happens is the anterior lobe of the pituitary gland and the hypothalamus are both sensitive to the levels of thyroid hormone in the blood. So as the levels of thyroid hormone in the blood increase, that will be detected by the anterior lobe of the pituitary gland, and perhaps more importantly, it will also be detected by the hypothalamus, because we now have increasing levels of thyroid hormone. And the increasing levels of thyroid hormone will inhibit the release of the thyrotrophin releasing hormone from the hypothalamus. So let's say that again, that's key. The increased levels of thyroid hormone will inhibit the release of thyrotrophin releasing factor or releasing hormone from the hypothalamus. So now we will have less thyrotrophin releasing hormone. We'll have less of that, less TRH. So now going to be less TRH, thyrotrophin releasing hormone. If there's less thyrotrophin releasing hormone, there's going to be less stimulation of the anterior lobe of the pituitary gland, so there's going to be less thyroid stimulating hormone. If there's less thyroid stimulating hormone, there's going to be less stimulation of the thyroid gland. If there's less stimulation of the thyroid gland, there's going to be less thyroid hormone produced by the thyroid gland. Therefore, the levels in the blood will start to drop. As the levels in the blood start to drop, that's going to remove the inhibitory effect on the hypothalamus, which will therefore produce more thyrotrophin releasing hormone, and that will go down that stimulating pathway. So this is all called a negative feedback system, because the end product, in this case the thyroid hormone, is inhibiting the release of its own releasing factors. So this is all a negative feedback. Negative feedback system. It's inhibiting the release of its own releasing factors. And the situation is the same with some other endocrine glands. For example, if this was the pituitary gland, it could release ACTH, adrenocorticotropic hormone. So if we're thinking that this was the system controlling cortisol, so there we would have the hypothalamus, and the hypothalamus would be releasing corticotrophin releasing hormone. Corticotrophin releasing hormone or releasing factor. That would then go down to the pituitary gland, and the pituitary gland would produce more ACTH. More ACTH. That is adrenocorticotropic. Adrenocorticotropic hormone. Adrenocorticotropic hormone, because that is stimulating the adrenal cortex to produce more cortisol. So it's the same sort of thing, and of course the cortisol would then inhibit the release of its own releasing factors in a negative way, in just the same way that the thyroid hormone would inhibit the release of its own releasing factors. So for several of the endocrine products, here we've looked at cortisol as an endocrine product in the blood, which of course needs to be very finely regulated. I mean, if there's too much of that, we have a special name for that. That's Cushing's disease. Cushing's disease would be too much hypercortisolism. And if there's not enough, that's got a special name as well. That's Addison's disease. And it's the same with the thyroid hormone. The regulation is so critical that we have diseases such as thyrotoxicosis or hypothyroidism that result from increased or decreased amounts. But that's always the physiological situation. The end product is inhibiting release of its own releasing factors via this negative feedback process.